So the question is, the function f is defined by f of s is equals to 3s plus 1 for s is less than or equals to a, and g of s is equals to minus 1 minus s squared for s is less than or equals to minus 1. Find the largest value of a for which the composite function gf can be formed. So now for this composite function gf to be formed, the largest value of a will depend on this f. That means the largest value of a we can get that from when f of s is less than or equals to minus 1, as we have a restriction here where a is equals to minus 1. So that means we can get it in this form. So I can also change the s to a so that I can work in terms of a, where f of a is less than or equals to minus 1. Or if you still say f of a is equals to minus 1 is allowed. So now, what is f of s? F of s is given as 3s plus 1. Then what is f of a? Anywhere you see x, put a. That is 3a plus 1. So now the largest value of a we can get here is 3a plus 1 less than or equals to minus 1. So any value of a I get here will be the largest value of a for which the composite function gf can be formed, because g depends on f here, because f is inside g. So that means this is 3a is less than or equals to minus 1 minus 1. 3a is less than or equals to minus 2. So a is less than or equals to minus 2 over 3. So that means the largest value of a for which the composite function gf can be formed is minus 2 over 3. So that is the answer for that question. So now the second one. Solve f g of s plus 14 is equal to 0. So remember, f of s is equal to 3s plus 1. So f g of s now, it means g of s is inside f of s. So f g of s will be like f. Now what is g of s? So g of s is all this value. So f g of s is f minus 1 minus s square. So that is f g of s. So now compare this with your f of s. If you compare this with f of s, it means s is minus 1 minus s square. So now anywhere you see s in f of s, then you can substitute minus 1 minus s square. So this will becomes f of minus 1 minus s square is equals to 3 minus 1 minus s square plus 1. So that is f minus 1 minus s square, because f of s is 3s plus 1. So that will be 3 brackets minus 1 minus s square plus 1. So remember that f g of s plus 14 is equal to 0. That means we know f g of s already as all this. So that means I'll have 3 minus 1 minus s square plus 1, then plus 14 is equal to 0. So open brackets here. This is minus 3 minus 3s square plus 15 is equal to 0. So this is minus 3s square plus 12 is equal to 0. So minus 3 plus 15, that is 12, equals 0. So minus 3s square is equals to minus 12. So s square is equals to minus 12 over minus 3. X square is equals to 4. So s is equals to plus or minus square root of 4. S is equals to plus or minus 2. So this should be the value of s, but we have a restriction in the question, that is for s is less than or equals to minus 1. So that means I have to ignore plus 2. So plus 2 is not allowed here because it's more than minus 1. So question says s is less than or equals to minus 1. So the only valid answer here is s is equals to minus 2. So that is the answer, because it is less than or equals to minus 1, as in like this. So we have to ignore the plus. So now let's do the last one. So the last one is find the sets of values of s which satisfy the inequalities. G f of s is less than or equals to minus 15. So the same way we did the that means f of s is inside G. So first, G of s is minus 1 minus s squared. So G f of s now is the same thing as G. So this is f of s, 3s plus 1. Meaning anywhere you see x in G of s, you represent it with 3s plus 1. So G 3s plus 1 is equals to, because G of s is this, so G 3s plus 1 will be minus 1 minus 3s plus 1 square. Anywhere I see s, I'll put 3s plus 1. So now expand the brackets. So G 3s plus 1, that's G f of s, plus minus 1 minus, open the brackets. So this will be 3s plus 1, another 3s plus 1. So now this G of f of s is given. So we said the G of f of s, everything is less than minus 15. But let's expand this so we can get G f of s. So that is this value. So we have used it. So now this is minus 1 minus, now open bracket. So that is 9s squared. That is 3s times 3s. Again 3s times 1. So that is plus 3s. Then plus 3s plus 1. That is 1 times 3s, 3s. 1 times 1, 1. So now G f of s is equals to minus 1 minus 9s squared plus 6s plus 1. So that is 3s plus 3s, that's 6s. So GFS equals minus 1, then minus 9s squared minus 6s minus 1. So I want to simplify further, so I will now use the G. So GFS is equals to minus 9s squared minus 6s minus 2. That is minus 1 minus 1, so minus 2. So according to the question, G f of s is less than or equals to minus 15. That means minus 9s squared minus 6s minus 2 is less than or equal to minus 15. So like that. Now bring this 50 in. We have minus 9s squared minus 6s minus 2 plus 15 is less than or equals to 0. So minus 9s squared minus 6s plus 48 is less than or equal to 0. So what can go in all? So 3 can go. So this is minus 9. Divide everything by 3. So this will be minus 3s squared minus 2s plus 16 is equals to less than or equals to 0. As in, we can actually form equation like this. So now this is quadratic equation. So factorize the quadratic equation. So if you factorize, so we can walk through this and remove this minus. If you remove the minus, the inequality sign will change. So this will become 3s squared plus 2s minus 16 will be greater than or equal to 0. So if I multiply everything by minus. So now, how can we factorize the quadratic? So if you watch my video on how to factorize a quadratic, you get that part. So now to factorize, we need the product and sum. Product here is 48. So and sum is 2. What are the numbers that can give us 48? And if you add, you are going to get 2. So we already know that 48 we have 2 in 48, 24. So 2 times 24 is 48. 2 again, 2 in 24, 12. 2 times 2, 4. 4 times 12 is also 48. 2 again, 6. 2 times 2, 4. 4 times 2, 8. 8 times 2 times 2, 4. 4 times 2, 8. Then 8 times 6 is also 48. So between 8 and 6, I can get 2. So this is 3s squared plus 8s minus 6s minus 16 is greater than or equals to 0. So bracket 2 3s squared plus 8s minus 6s plus 16 is greater than or equals to 0. So s is common here. So it remains 3s plus 8 minus 2 is common here. So that's 3s plus 8 is greater than or equals 0. Remember, this is 16 in the brackets. So now this and this are alike. So this will becomes 3s plus 8 s minus 2 is greater than or equals to 0. So take the outside one, s minus 2. Also take one of this, 3s plus 8. So to do this with normal proof in inequalities, to show the full workings, we have to draw a number line. But I've actually solved this without number line. So out of these two numbers, this number is less. So if I use the techniques of let me use the techniques, that is, I've said if a is less than b, so I've proved this, that is s minus a s minus b is greater than or equal to 0 will be like s is less than or equals to a, or s is greater than or equals to b. So you can know this. so that instead of wasting time in solving inequalities, this will go in line with your inequalities. So now if you compare this is the same thing as 3s minus 8 and s minus 2 is greater than or equal 0. So that means our a is minus 8 because it's less than 2. So answer will be s. So answer will be s is less than or equals to minus 8 over 3, or s is greater than or equals to 2. That will be the answer for the inequalities. So we are going to ignore this positive because the restriction here is that s is less than or equals to minus 1. So we are going to pick this one as answer. But if we show the full workings, so instead of using the short form like this, so you can now use a number line to show the full workings. So we have a number line. So now make this equal to 0. So that is 3s plus 8 equals 0. S is minus 8 over 3. So minus 8 over 3 will be somewhere here. So negative side. And remember in your inequalities, this is negative infinity, this is positive infinity. So now set the second one also equals 0. S is equal s minus 2 equals 0. S is equals to 2. So let's say this is 2. Positive. Because if middle is 0, so we have positive side and negative side. Now we have 3 regions here. This is 1, 2, 3. 3 regions. So now for this region, we have, remember we have greater than or equals to 0. So this will be our 2 critical points. You have to take it because of the greater than or equals to. So now this region is like from 2 and above. So now pick any number in this region from 2 and above. So let's say 3. So now for these two brackets to be true, it means this one times this must be greater than or equal to 0. And for it to be greater than or equal 0, the two results must be positive, positive. So now pick any number here in that region. So now 3, let's say 3. If you put 3 here, 3 times 3 will be 9. 9 plus 8 will be 17. That is a positive result. If you put 3 here, it will be 3. 3 minus 2, 1. That is a positive result. Positive times positive will give us positive. So that means this region is true. This region is true, positive. Now, there is a trick again. If the power on your bracket is 1, 1, as in 1, power 1, then the sign will alternate. The next one should be minus, the next one should be plus. But let's show it. Now, pick any number in this region that is minus, this is roughly minus 2 point something to 2. So pick any number in this region. So let's pick 0. So if you put 0 here, 3 times 0 is 0. So it remains 8. That is positive. Times, put 0 here. Then this is minus 2. That is negative. Positive times negative is negative. So the second one is a negative result. Now the third one. So the third region. Yeah. So pick any number from negative 2 to negative infinity. So here, this is roughly minus 2 points something. So now let's pick minus 3. Any number in this region. So pick minus 3. So minus 3 times 3, that is minus 9. Minus 9 plus 8, that is minus 1. That is a negative result. Times, put minus 3 here. Minus 3 minus 2, that is minus 5. Another negative. Negative times negative is positive. So this is a positive result. Now, according to your inequalities, the result is greater than or equals to 0. So these are the region that we are going to pick here, as in, and here, because those are the positive results, because we have greater than or equals to 0. So the positive results is our answer, because it is more than 0, greater than or equal to. But if it is less than, so I'll pick this region. So my answer now is this region and this region, so which is the same thing. If you look at this is x is less than, or x is less than or equals to minus 8 over 3, or s is greater than or equals to 2, as in this region, because all these numbers are greater. So that will be the answer. So you will see this is the same thing as the previous one that I shown. So the previous rule that I said I shown. So instead of passing through this stage, so but for here now, our answer is minus 8 over 3. I will ignore this one because the restriction is s is less than or equals to minus 1. So ignore the positive. So the answer is s is less than or equals to minus 8 over 3. So that is the final answer in that question.